Good morning, everyone. I'm Sabriel, and I'm going to be interviewing Sabriel. Thank you, Sabriel, for having me. Now, let's start off with asking you, what is ionic bonding? Sabriel, I get asked this question a lot. I'm going to tell you what it is, okay? Because I know, because you're interviewing me, so I should know. Well, I'm just going to name this off the top of my head. Ionic bonding is a type of chemical bond that involves electrostatic attraction between oppositely charged ions and is the primary interaction occurring in ionic compounds. The ions are atoms that have lost one or more electrons, known as cations, okay? And atoms that have gained one or more electrons is known as anions, okay? What about a covalent bond? Ah, yes, covalent bonds. That's my favorite of all the bonds. Well, a covalent bond is a chemical bond that involves the sharing of electron pairs between atoms. These electron parts are known as shared parts or bonding pairs and are stable balance of attractive and repulsive forces between atoms. When they share electrons, it's known as a covalent bond. Well, can you give me a little explanation of valence electrons and how they are related to each type of bond? Man, you just want explanation after explanation. How I'm going to tell you what valence electrons are. The electrons in the outer shell of an atom. The valence electrons are the ones involved in forming bonds to adjacent atoms. Therefore, the number of valence electrons is important for determining the number of bonds an atom will form, the number of unpaired electrons, and an atom's formal charge. Can you give me one more explanation about, say, how periodic trends affect bonding? Sabriel. I'll tell you exactly what it is. Thanks, Sabriel. The simple answer is the ionization energies and the electronegativities of the bonding atoms give an indication of how evenly or unevenly the atoms will share electrons, resulting in covalent bonds. Polar covalent bonds or ionic bonds. Isn't that just great? Now let's get into these demonstrations. Sodium and chlorine. Sodium has one valence electron. Chlorine has 7 valence electrons. Now, these are combining ionically because it is a metal and a nonmetal. But when they combine, there's an explosion. Well, Sabriel, can we get a demonstration of a covalent bond? Why, yes, of course. Hold on, let me drink. I'm thirsty. Oh, water. That is a good example of a covalent bonds. 2 oxygen, hydrogen covalent bonds. Right, you know what I want? Give us a demonstration of how valence electrons and how they're related to each type of bond. Precisely! Well, valence electrons are the outer electrons in the outer shell of the atom. Atoms like to gain or lose electrons in order to become more stable. For an example would be probably calcium. It has 2 valence electrons. To become more stable, calcium will lose its 2 electrons to get a positive charge of 2. For example, with its 2 valence electrons, we have our Lewis dot structure. Then, after it becomes more stable, we have our symbol right there. Well, how do periodic trends affect bonding? Well, let's take a look. Periodic trends affect bonding because of how elements are arranged on the periodic table. As you can see, ionization energy increases, going right and up. Atomic radius increases, going down and to the left. It's all part of the periodic table, as we can see in the back. Alright, thank you for your time, Sabriel. Yeah, whatever.